Hello and welcome to Console Cowboys. This is going to be a really good video if you've been trying to use Binary Ninja to do some reverse engineering. This is quickly becoming one of my favorite tools for reverse engineering. We're going to take a look at the way IDA's workflows are, the way Ghidra's workflows are, all the specific Binary Ninja stuff, a little bit of scripting if you were going to do some automated vulnerability analysis or just automated analysis in general, how to use some of that Python scripting stuff within the Binary Ninja API. So if this all sounds good to you, let's hop right in here and get started. So when you open up Binary Ninja, you're going to be at this screen. You have a couple different options. You have Open, which selects all the things that it thinks is best for you when opening up a binary. Then you have Options. Now if you click Options and you select a binary, it's going to give you that pop-up kind of like IDA, where you can select all the options you want. You can disable the linear sweep, or you can change the architecture or what have you. Usually all the defaults are pretty good, so I'm just going to hit Open. So the first thing you're going to notice when you look at this code is it's really short. This is the same binary that we used in the Radar 2 tutorial that we went through, and you'll notice that this one has a main function. We have our puts, we have our fgets, and then we go into a function. It's very, very readable. And that's because we're in something called high-level IL up here. You can switch all the different views up top. If we wanted to look at the disassembly view, this looks a little more familiar to us, and we see all the disassembly and the nitty-gritty details. But Binary Ninja tries to help us out. It'll add values there that it calculated in different views, and then some of them are more granular like this. This is our disassembly. We have our low-level IL, which shortens it a little bit for us, makes it a little more readable. Our medium level, which shortens a little more. And then we get into that high level we were in, and we also have our pseudo C representation. Now, also like in IDA, we're in this block mode at first, and if we hit the space bar, we're in the disassembly view here. Now, this is a little more apparent if we open up another binary. So if I open this up and we'll say go to crack me 3, you'll see here, okay, we have a whole bunch of different basic blocks, and we have it in this graph mode, and you can scroll around exactly the way you would in IDA and kind of figure out, the flow of the application. So that's pretty cool. Now let's say, okay, I'm used to Ghidra. I like my workflow in Ghidra. I want it to be like Ghidra. Okay, cool. So let's do our disassembly. So we have our disassembly, and we have our disassembly pane. We can split this pane up here, and then we can just hit pseudo C. Now we have it exactly like in Ghidra. Here is our function, right? This is our check password function. And if we click stuff in here, it will move around within this other pane because they're both linked together. But we have our assembly on one side and we have our C code over here on the other side. But you can also hit the space bar in one of these, and now you have this in the graph mode. And then the other side, you have it in C code. So you can see the flow of it, and then you can see it over in the C code. So I like that view a little better than Ghidra. Also like Ghidra, you can start modifying this code so that you can make sense of it a little better. So if I hit the N key here, we know that Joshua is that password that's getting string copied. So we can say password. Boom, we have that. And then we have our argument coming in. That's our user input. So let's say I didn't know that hotkey. I can right click that. And we say rename variable, and it also gave us our hotkey there. We could say, okay, this is our user input. So now we say, okay, cool, we can read things a little better, string comparing our password, our user input. We know that's our password, Joshua. We pop it in and we, crack the binary if this was a CTF of some sort, right? So that's pretty cool. Now, the other thing that makes it kind of like IDA is we get hit the space bar, go between, you saw that, but you can also hit the G key like in IDA, and you can go to any address. Hit Control F and we can search for things just like any program, the find key. So that's also pretty cool. And then we have things like our cross references, right? So if we were to go into our, go to our high level IL here, and we have our result, and we want to see, okay, where is our access granted being called from? You can look at, here's our cross references down here, so that brings us back to where it's being called. But we could also say, okay, we want to tag this for later. Maybe we're doing some reverse engineering of some firmware. we went down, we found some P opens, some system calls, and we wanted to catalog all of these for later to kind of trace them back up and find the vulnerabilities. We could right click this and say tag selected rows. So if we click this and there was like 20 of them, select them all, hit tag selected rows. We'll say these need a little bit more analysis, hit select. And we can go over here on the side and here's our tag. And these are all the tags that we selected. We can remove these tags, copy these tags, go to the next tag, etc. And we can kind of keep track of the different cross-references that we want to look at later on, depending what we were analyzing. Maybe we wrote some Python code. We found all of the P opens and then we cross-referenced them all. We tagged them all. And now we're going to go through them one by one and check each one for vulnerable, user input coming into the application, right? So that's something that we can do with the cross-references, and that's how the cross-references work. They're just down here in that pane. So that's also something we can do. Now, another pretty cool thing is let's hop back into a main function here. Now, let's say we didn't have these addresses in here because by default you don't. We can hit something like Control P, which opens up our command palette, and we say show address. And it brings these things up. So if I click that now, all of our addresses are gone. If I do it again, show address. So this actually gives us all of our options from the menus, but we can search for them through that command palette. Another thing we could do if this Python terminal wasn't open, we hit the back tick, and that will open up the Python console that we can do stuff in there. Now let's say maybe we're doing some malware analysis and we need to understand what this program does at a high level, and we want to look at the imports and the exports because the imports will tell us, what functionality might be available in this program. So we can say, okay, view, and we'll go to the triage summary, right? And we have our MD5, our SHA-1, so we could search these online and find them on VirusTotal or find somebody who did some dynamic analysis and look at their starting point. And then we start looking through at all the imports to get an idea here. Okay, we have some printfs, we have malloc, we're doing something with memory, doing some string compares, but if this is a Windows binary, maybe it'll show us, virtual alloc, and it'll show us different cryptographic functions that it's pulling in for doing some encryption, etc. So that's how we can check on that. So that's one thing that's useful. Another thing that's like IDA is, you hit the escape key and we go right back to the previous thing we were looking at. You can also in here hit the Control Z key. So if we go back to main in this walkthrough, let's go here and we'll say, oh, actually we're already in here. So here's our password. We change that to password. We change this to user input. If we hit Control Z, we can actually go backwards, and now we're back to var 13. We're back to arg1. So there is an undo, which is something that wasn't in IDA for a long time. I believe it's in there now. That is available in here, so it's good to know about. Now from the side pane here, you can get to all the functions as well. So that's just something good to know. And you can do some searches up here for stuff. And you can see all the cross-references down here, right? So this is very familiar to what we're used to in IDA. We also have a debugger up here if you want to play around with that as well. And then we have plugins. So this is an interesting feature as well. So we can go to Manage Plugins, or we can hit Control-Shift-M, and we'll bring up the plugins. Now you'll notice like this one is in orange and these ones are in white. The ones that are in orange are the official plugins. The ones that are in white are not official. And notice up here, you'll see stuff like @installed, @enabled. So if we were to go to this architecture, you'll see this category is architecture. So we could say @AR arch, and then it starts bringing up all of these architecture plugins. These are all architecture. So that's how you can kind of filter out, what you want based on the categories. Now let's say we want to install something. Maybe we're doing some Ethereum stuff. So we have this Ethers play. So we can look at this plugin and say, okay, Binary Ninja plugin enables EVM disassembler. That sounds good to us. And we say, okay, this supports Python 3.6 and above. Ensure that your Binary Ninja's Python library is set to 3.6. Okay, so we need to change that in our advanced settings. So we could say, okay, well, let's go to Edit. Let's go to Preferences. Let's go to Settings. And let's make sure our Python is set correctly before we install this. So open up here and we'll say Python. And we'll find the Python settings. It's really easy to find out what you need. You don't have to click through everything. You just search for it. So we click Python here and we'll say, okay, Python interpreter. And I already modified it, right? So I selected something. By default, this will be blank and it just uses the default. For this particular plugin, you actually need to select something Python 3.6 or above. So I have 3.10 selected, so it should work. So if I get out of here and go back, I can hit install. And then it'll say, okay, these things are what you need. Would you like us to install these dependencies? And I'm going to say, yeah, sure, of course I want you to install these. So we'll wait a second for that to install. Once that installs, we'll have the disable and uninstall options. And if we look at it, it says enabled right here in green. So now we're able to open .evm files. So I can say file, open. Otherwise, it wouldn't understand what this is. And we'll say, okay, this recurse.evm, which is just a binary that I stole from the EthersPlay examples. And you'll see, okay, here is another flow graph. And we'll see the things that we noticed. If you were doing my Python Web3 hacking course, we went through a lot of disassembly and then automating stuff with disassembly and then how to manually figure out what all this disassembly is doing. So if you're interested in that, you can go check out that playlist for Web3 Python hacking. And you'll notice, okay, push one, call value, and you can go through and here's the flow. And then if you want to look at this in a different representation, you can see, okay, plugins, EthersPlay, what other options do we have? We have something for Manticore highlight to highlight something that was symbolically executed, I'm guessing, that the paths that it took. And we could say, okay, render flow graphs, and that just shows you a different representation of the flow graph. So those are the options for that particular plugin. So depending what that plugin does. Now there are a lot of plugins that are pretty cool, right? So I have like SE Ninja installed, and that's if you're doing symbolic execution. And then, my debugger's installed, so I can do the debugger stuff. So that's how to use plugins, how to install them, and then, add functionality. So like we saw, if you go back into Control-Shift-M, and we look at the plugins again, you'll see, okay, look, we were doing some, binary analysis of NES ROM, so we can install this architecture plugin. That way it'll understand what that NES ROM actually is and know how to disassemble it properly so you can take a look at it. So cruise to here, check out this, look them up online and just get an idea of what might be useful for you, right? So here's like a plugin to embed with the Ghidra decompiler if you like the look of that a little better than something else. So give those a try. Now let's take a look at some other stuff. So let's say we want to change representations of data. So if I was to open up another one here, let's see, we'll go to this Crack Me Elf. And I'm looking through this and I see, okay, if var88, which looks like it's coming from some user input somewhere, right? It equals 0, then it's going user input, then they're comparing it to this value here. And if it equals this value, it's going to go to great job. Well, what if I don't know what this value is because it's like in hex representation? Well, there's a couple things I can do here. First, I could right click this. I go display as, and I go, okay, it's a decimal. Okay, that is my decimal value. Now I can use that and I can beat the Crack Me and, win the challenge. Yay. Or if I hit Control Z and we'll switch it back, if I copy this and just put it into my Python terminal, it will also give me the proper representation. Now we have that 412669250, the same as we did when we did the display as up here. We can compare it right now, display as, and look, 412250, perfect. Now, let's say, okay, I didn't know what that value is. Maybe we're looking at the disassembly here and we're like, okay, we don't have that value here. It's saying just JNE, right? Okay, well, I know that if I put in the wrong password, I'm going to this, I'm sorry. So let's just crack it. Let's say this is a video game and it has a 30-day trial, and I want to say, like, when it hits the 30-day trial, I want to reverse the logic. So I can just do some patching. I can go to patch and I go, hey, I can always branch. I can invert the branch and do the opposite of what I want to do. I can never branch. So let's say we want to invert the branch. We're going to go from JNE to E, right? Instead of jump when not equal, we're going to go to jump when equal. So now if this was checking if I had a 30-day trial reached and I already had that 30-day trial reached based on the clock, then now it's going to say always give him access to the video game when he reaches 30 days. So perfect. Now I can keep playing that video game. But let's say we wanted to do something a little more granular and change it to something specific. Well, we can hit the E key here, and that will allow us to do some inline assembly, and we can just change this value to whatever we want. And it's a little smart, so it'll add in some nops there if it's a little shorter, or it will overwrite something if it's a little longer and try to fix it for us. But another thing we can do here is we could select this whole box here, and we can hit E again. And now we're able to modify all of these values in here and just change things around a little bit and change the functionality. Then once we get it the way that we want, we can go up here and we go File, we do Save As. We say, okay, let's save the contents only of, the changes that we made. Just hit save, and we can, choose a binary name, and we have a new correct binary, and we could run that binary and bypass whatever we need to from now on. So that's how to do patching. So there's a lot of different ways to do it depending how granular you want to get, right? So that's most of the UI functionality. Let's take a look now at a little bit of scripting. So let's figure out how to do stuff in the API, how to search stuff in the API, understand how things work. So first off, we're in this crackme.elf. Let's go through and let's look at all the functions in this program. So here's what we're going to do. We're going to say for functions in BV binary view dot functions, and binary view is just like that top level thing within here in the API that we can search through. We're going to look at the functions in there. And we're going to say in there, let's do a print functions. Then we'll just hit enter, and we get all of our functions that are in there, right? So we have our, let's see if we recognize anything. We have a sleep function in here. And if we click that in there, notice it also went to this sleep function within the disassembly, which is also pretty cool. We have our print functions, fgets, put, right? So those are different things. And then if we take this same exact thing and we go into, say, this crackme3 here, and we hit this again, we'll get all the functions in here. So it's whatever one that we are currently in. And in here we see, here's our main function. And what else do we have? Stringlen, malloc, string compare, and you'll notice it's just changing all of these things up here. So we can kind of just enumerate all of this stuff in here like that. And let's say we want to go a little bit deeper. So we're in this main function here. You're going to notice that we have our function name, and then we have all these blocks is what we call them. These are our basic blocks. So let's say we want to enumerate those. So we'll say for function in bv.functions, we'll say for block in function, we're going to print block, and then we'll get all the blocks within all the functions. This is how to start going a little deeper in there. So then we can go one more level than that. So we'll get rid of this print statement, and we'll say, okay, well, for each instruction in block, let's print out our instructions. So print instruction, right? So now what we're going to do is we're going to go, okay, well, we're in this function, right? We're in main, and we have each of these blocks. How do we look at each one of these, like this char star EAX, sub, etc.? We want to look at all the functions that are available within all these blocks. We'll hit go there, and here are all of the different, items here. And I believe you can click some of these things and it will actually open up here depending what you're clicking. Right there, I clicked an address, it went to that address, right? So some of these things are actually linked up to this disassembly as well. So let's say now we want to search for something specific, right? So let's say we want to search for string compares, right? We're wondering how many places in this binary are they doing string compares, because we care about when they're comparing our user input. So say, okay, count equals 1, and we're going to make a function. We're going to say for function in bv.functions, and then we're going to do a little bit of logic here. We'll say if strcmp, string compare, that should be correct, is in the casting of the function to a string, so function, right? Because if we just say string compare in function, that's not really a string, it's something else. So we gotta cast it to a string. That way all of those functions that printed out are in string form, and we can check if string compare is in there. And within here, we're just gonna say, okay, let's do a print, and we'll say this is gonna be an F string. So we can put the variables in here with strings, and we'll say, okay, found, and then we'll just do our count. So we'll do count, and this will just tell us how many it found as it goes. And we'll just say, okay, well, we also need to say count equals count plus 1. So each time that it goes in this string compare function, because it found something, it's going to add 1 to the count. And then we're just going to run this here. So let's do that. And this says that we have 1 string compare within here. So if we go also Control R, this will show us all the previous things that we did. So let's scroll up and let's find where we printed our functions. That would be right here. So let's print out our functions. We'll hit enter. And now let's count our string compares. So we have a string compare here. And when we clicked it, it goes to it. We have scroll down, and I don't see any more string compares. So that correctly found that we had 1 string compare within, this binary. So let's say maybe we were looking for, system calls or p opens. We were looking for vulnerabilities. We could write some logic that found all of those, and then we could click those and then start adding those to, our xrefs and all these different things, or automate all of it so that it's checking for very specific things on maybe vulnerable functions. So that's just something to think about. So now let's say we want to look at strings, right? So we can look at strings up here. If we click these quotes, this will show us all the strings within this. And if we double click them, it'll go to these strings. So that's one way to look at it. Now, another way to do it is programmatically. So we can say for string in bv.strings, let's just print out our string. And this will print out all the same strings that are up here, right? So here's all of our strings that are within this binary. And then we see, oh, like here's this, base 64. I wonder what that is. Could that be our password in here? I don't know. Let's find out. So let's say we want to do base 64 and we don't know how to do that. So let's look it up the API. So we'll say binary ninja base 64, and we'll see what pops up. And we see, okay, there's a transform module in binary ninja. Let's take a look at what's going on in here. So we have, okay, list transform, base 64. So we could do that in our console here. So we'll say copy, go back to binary ninja, we'll say paste. This will list out all the different transforms we can do, right? So we can do some des CBC. We can do some carry 08, all of these different things. But what we care about is the base 64. So let's see how to use it. So we can see, okay, what are they doing here? If we search for base 64, we see that comes in the output here. Is it anywhere else in here? Okay, I don't see it anywhere else in here when I search. So let's see how they're using it. Okay, so here's how to use XOR, and we say transform XOR. We're making a variable. And then we're saying XOR.encode. So there's probably a decode function as well. So let's try that out. So base 64 was right here. It's capital B base 64. So let's go back, and here's what we'll say. We'll say base 64, so we'll make that variable, and we'll say that that equals transform, and then we'll do base, capital base, 64, put that in quotes, and now we have that variable here. And then what we're going to do is we're going to say base 64, and this time we're going to do a dot decode because we'll assume it has a decode function. And then we need to put our string in here. So let's grab the string that we saw within this output, say copy, and let's find out what we got with this. So we'll say paste, put this in quotes, close that bracket, and there is our base 64, and it looks like it's a string for your second lesson, unbase, blah, blah, blah. So this is from a try hack me, and now we know what the password is. So that's how we can do that, and how we can look at the APIs online and just get an idea, how those are used, and then use them within the Python console to automate some stuff for us. So let's say, okay, we want to find some more strings now, but we want to search for something specific. We want to find maybe something with a password in it. So we'll say, okay, let's say bv.find all underscore text, and we're going to say, let's do this from bv.start to bv.end. So we're going to check the whole binary from the start to the end. And if you look up in the API, you'll also find this stuff as well. And we're going to look for a password. So anything with the text password, let's see if anything pops up. We'll say find, and that gave us back a generator object, so we can't see that. So one thing in Python you'll notice is when you get back something like that, where it's an object, if you encapsulate this here in parentheses and you put list in front of it, usually you will get what you want. And this goes for regular Python, not just this terminal here. So hit that, and then we see, okay, we have password listed here. And then we have correct password, and we have password here. So this is just all the places in the program that have what we want. So that's how to search for strings in there. That's how to transform some strings. And then also we showed you the Control R, which shows us, here's all the stuff that we typed in here if we need to go back and do that. There's also some stuff too. So within the plugins, you can install something called snippets. And then you can open up a snippets editor, and within here you can make snippets of code that do things and then just run all of that code. So that's how you can make a little bit longer programs and not do it within the Python console like that every single time. So I think that is enough information for everybody now to really get them started using this for scripting, using this for reverse engineering, depending if you're coming from IDA or Ghidra, and how to get that commonality of workflow that you're looking for, as well as leveraging specific stuff for Binary Ninja. Hopefully this was informative and you learned a lot. If you did, hit the like button. You can subscribe, and also you can follow me on Twitter if you want. It's in the description below. Have an awesome night, and I really hope this was useful to you. I had fun making it. I love Binary Ninja, and I hope you'll make use of it.